Welcome to Chemistry with Dr. G. In this video, I'm going to talk about reversible reactions and equilibrium. So what is a reversible reaction? So in some chemical reactions, when the reactants react to give the product that have been produced can react back together to give you the reactant. So this kind of reactions are called reversible reactions. Reversible means we have two types of reaction happening at the same time. One of them is called the forward reaction, where the reactants react together to give the products, and the other one is called the reverse reaction, where the products react back again to give you the reactant. When we represent the reversible reactions, we use these two arrows instead of that arrow which represents the normal one-way reaction. One of the typical examples of reversible reactions is the Haber process, which is the reaction between hydrogen and nitrogen to give ammonia. So what's equilibrium? When a reversible reaction occurs in a closed system, equilibrium is reached when the reactions on both directions take place or happen at the exact same rate. So what do we mean by closed system? Closed system is that system where nothing escapes and nothing gets in. So that's basically a closed system. None of the reactants or products are allowed to escape or anything to get to the system. So if the reversible reaction occurs in a closed system, equilibrium will always be reached. And when equilibrium is reached, the both reactions will take place or will occur at the exact same rate. So let's have a look at this reaction. This is a reversible reaction where we have two reactants A and B that react together to give C and D. So how can the equilibrium be reached? So at the beginning of the reaction, the reactants A and B will react together. As they start to react together to give C and D, what happens is that the concentration of A and B will be decreased. So the concentration will be decreased. If the concentration is decreased, that means the forward reaction rate will also decrease because we know that concentration affects the rate of a chemical reaction and decreased concentration will decrease the rate of a chemical reaction. And then at the same time, once A and B react together, they start to give the product C and D. So C and D will start to form, which means their concentration will increase. Once the concentration of C and D increases, that means the reverse reaction rate will increase because the products which start to react together, their concentration increases. So now we have the forward reaction rate decrease, the backward reaction or the reversed reaction rate will start to increase. This will continue until an equilibrium state is reached. At equilibrium, the rate of both the forward and reverse reaction will be exactly the same. So the system now will be at equilibrium. At equilibrium, both reactions, forward and backward, are still happening. However, the rate of the reaction is on both ways is exactly the same. The concentration of both the reactants and the products will be unchanged. So they are not going to be the same, but they will be unchanged. So at equilibrium, the concentration of reactants and products are not the same. So even though the rate of the forward and backward reaction is the same, so there is no net change in the whole system, but the concentration is different. They just reached a point of equilibrium where the ratio of concentration of both reactants and products will remain the same. So the ratio between them will be exactly the same. So if we say, for example, the ratio is 1 to 2, for example, reactants to products, then at equilibrium, it will always remain like this. So it's not going to be changing. This is called the position equilibrium. What do we mean by position of equilibrium? That means where is the higher concentration of the which side has the higher concentration, basically. So sometimes the position of the equilibrium will be to the right. If it's to the right, and we are looking here at this reversible reaction, if the position of the equilibrium is to the right, that means we have higher concentration of the, and if the position of equilibrium is to the left, that means we have higher concentration at equilibrium of the reactant. So it depends on whether the position is to the right or to the left. That's affected or that is determined by the final concentration of the reactants and products at equilibrium. So the position of the equilibrium will depend on certain conditions. These conditions are temperature, pressure in case of gases, and the concentration of reactant and products. Le Chatelier principle is the principle that explains these factors and how they affect the position of equilibrium. So in the next video, you're going to find a full description and explanation of what is Le Chatelier principle.